Hi, I'm just going to talk in the name of the group, and I want to say thank you to Connie Mitchell because she's our support in the HESI group. Next slide, please. So this is a newly formed group, and as you can see from last year when we provided an update on what we wanted to do as a group, it was very high level. Now we have actually put together a group, and we have a very good representation between industry, academia, nonprofit, government, and consultants. So I just wanted to say thank you to all for coming forward for this discussion. Next slide, please. So to get started, we put a purpose of the group, and the idea was to evaluate error corrector sequencing technologies as a potential tool to measure clonal expansion as an early tumorigenicity biomarker. But we're concentrating mainly on non-genotoxic compounds. There's a whole group in HESI called GTTC that they are working with this technology in genotoxic compounds. So we need to make that differentiation because there's a lot of subtleties in that. So it's important for that. Next slide. And on that note, here's there's a couple of groups within HESI that are working on these error corrector sequencing. So we just have put this slide together. Actually, HESI put it together where they want to say where they are, where they're using this technology and how we are trying to use it and a different endpoint. So the C tracks that it will there's the GTTC that I just mentioned, and in the eSTAR, we have these non-genotoxic carcinogens that we want to talk about. Next slide, please. So how does this potential approach will help us in an overall carcinogenomics? So as we have discussed in the past, and it will be discussed later today, is about the gene transcript and how they can distinct tumorigenic mechanisms. So that's been going on for years. What we think with this new technology, we could try to expand and understand if there are clones and advantage clones that are indicators of carcinogenicity, especially under these same routes of mechanisms of actions like AHR, ER, CAR. So that's kind of what we wanted to try to identify. That was the principle. Next slide, please. So I just want to have this slide. This is a high-level summary. So that's how we started last year, where we had a study. There was a proof of principle study that was conducted in collaboration with a couple of groups. So it was Taconic, it was Charles River, it was Pfizer, it was Merck, it was TwinSan. And the idea was to prove, can we really measure these clones and this clonal expansion when we have different exposures? So we did a couple of different studies. And they were one where we concentrated on non-genotoxic carcinogens, where we tested baxdrosine and PCB126. And just very briefly, the study design was to get these transgenic TGRAS animals, and we dosed them for 1 month, 3 months, 6 months, and then we saw the tumor at the 6 months, and then at 3 months we measure and see could we get clones. So in the lower left-hand side, you can see a little bit of the clones. They're not very big. We have covered this in many other meetings, but I just wanted to give you a kind of a refresh of what we were planning to do and that we actually were able to. So we were able to see the clones at 3 months, especially, of course, for ENMU, that's a carcinogenic compound. That was not a surprise, but we were able to see the baxdrosine in the ovaries as expected, and we were able to see some of the clones in the livers with PCB126 as expected. So that gave us the principle at the basis of this study, of this group. So if you go to the next slide. So with that, we had been thinking about through the years, what do we need to do? And there's a lot to do because this is just one study, one proof of principle, one technology. So we were thinking there are many different things we had to do, and we tried to kind of split them up and bucket them into things that we think we need to look into. One of the first things we decided, and that's where we have mainly concentrated, is the first one. Can we do additional studies? Can we have additional compounds that we can test? Is there other mechanisms we can do? So with that on hand, we went out and started, if you go to the next slide, please. And we did actually a call for different people and say, do you have samples? These studies are not simple, so we cannot do doing the actual studies is much complicated. So we thought, let's start to go out and see, can we collect samples? And as you can see here, we were actually extremely surprised and pleasantly surprised that they were available. There were studies available that we can potentially use to kind of start continue proving this hypothesis. So we just divided available samples based on studies. With the studies that they already have some type of error corrector sequencing done, and see if we can change technology if they use the CAR-seq or they use the DNA duplex sequencing. So we divided it, and we have also potential new studies. So that's kind of where our thoughts were. So I'm just going to walk you through very, very briefly on the studies and what type of data are we having. So if you go to the next slide, please. So first we have a phenobarbital. So this came from MCAR, and they had samples, and they have samples that potentially could be used, that has long-term duration plan, that it has a non-genotoxic mechanisms. What we liked of this study is that they have two strains, one more sensitive than the others. So we have potentially could use that to answer some of the questions. So this is kind of very high level. So these samples have potential to be used. You go to the next slide. So then we have these that came from one of our calculators, Syngenta. This is a very nice study design where actually they did with this compound, it's an analog, it's an unknown compound, that they had carcinogenicity data, and they had the tumors in the livers, and they had sample for the 90 days. So that's also very potential. There's a non-genotoxic mechanism goes through CAR, and the samples were available, and potentially we had also mice and rats, males and females. So that's another idea that we thought these samples are very good for us to keep in mind. If you go to the next slide, please. And here we have Furan, and I heard and I saw in the chat, it's not from University of Ottawa, it's from Health Canada, that have some samples there that we can use. So that's another potential one. And then go to the next slide, please. And CTR, this is where we're going to do some type of swap. They already have done some error corrector sequencing. We might want to see if we can do some of the PCB samples, and then at the same time allow us to compare two technologies, and so we don't have to focus on only one. You go, next slide. And then this one is a big study that although it's a genotoxic mechanism, it's a huge study that is done by University of Ottawa. Carol, I hope that's right. If not, let me know. But what we like to
and study Health Canada. And Health Canada.
And Health Canada. Okay, thank you. And then what I want to make sure is that even though it's a genotoxic mechanism, there's just a lot of data. There will be a lot of data generated on that endpoint. There's a lot of samples that will be generated. So it will be good to keep it in our back pocket to see if there's some questions, specific things we want to answer. So I just wanted to put it out there as a potential. Yeah. Go to the next slide. So again, just to summarize, so we have samples. It doesn't mean this is it. We're looking for samples. So if somebody in this call have sample in the freezers and that they have some understanding of mechanism, they know it's not genotoxic. If they have carcinogenicity data, that would be great. But if they have 3 months, 6 months, or longer sample, that would be great. So we're still looking. But what I think is good is we have something to start with to help us start actually mapping out and shaping up better these hypotheses. Next slide. So again, so in 2023, we have been able to do this inventory. We recruited a good number of people, so that seems the topic is very is interesting for a lot of us. So it's good to have a good group of scientists that will help us. And we began doing a study design, and that's where I'm going to talk a little more in the next couple of slides. And I'll explain what that means. Next slide, please. So one of the things we were discussing, so we have the samples, and then we said, okay, so which ones we're going to test? And then the first discussion we have is bunches versus homogenates. And Megan, please chime in anytime. What happens is in the initial study, a pilot study, when we did the sampling for the clones, it was based on bunches. So there was very specific bunches we did for very specific sites within the liver, where we wanted to make sure we were able to kind of replicate where we had the finding if we did it. But there were questions within the group, do we really need to do the punches. Can we use the homogenates of the liver? Especially with doing DNA duplex sequencing, we're supposed to be very targeted, and we were supposed to make sure that. So that led to a whole new first study that we thought it would be important for us to run to understand this question, because it's critical, because that also will help how much sample we need. If you have it in the freezer, how can we use it? So with the imidazole analog study, we decided to do that understand that first question. And if you go to the next slide, please. The first question is, so we decided to go with that study because it had a lot of material that we could use. We had the carcinogenicity endpoint, so we knew that in the 2-year CARSA study, there were hepatocellular carcinomas in males. And we had a 90-day duration. So we're kind of answering 2 questions. First, we're going to use these samples to try to answer these punches versus homogenates. So we're going to divide the samples and try to do all that. And second, of course, the idea will be we should be able to see if we can see the clones. So it's kind of 2 in 1. And we're trying to figure out the best way to design it. So there's a whole study design team that is going to get together. So we answer all these technical questions and make sure we have already the questions about what we want to get from the clonal expansion. We get to the next slide. So this is where we are. It has taken a time to get to there, especially finding the samples, then making sure what we wanted to do. So we are in the experimental stage. So we have a group of people who has volunteered to put a study design, how we're going to really do this study design and what were the questions, especially in the technical part. We're learning a lot from the GTTC. The GTTC have done a lot of work in DNA duplex sequencing about the technical part. So we are co-pollinating, learning from them so that we can teach us and they see how we can apply that in our this clonal expansion space. We need support. Of course, we want a lot to do, and these technologies are not cheap. So we're getting a lot of in-kind support for our group. So we're getting, we have had volunteers that are willing to do the DNA extraction. We have volunteers that are willing to do the library preps. We have Twinstar that had given us some of the duplex sequencing kits discounted. The sequencing part, that's the part that right now we know is the most expensive part. We're looking help, but we have to figure out how to do that and people to do the analysis. So this is where we are. We're still looking for volunteers. So if anybody wants to come and help and support any of the stages, or if you have samples, I still insist on the samples, because the more samples we get, the best, meaning the more we can really prove this hypothesis. So if you go to the next slide, please. So in summary, we made a great progress. A year ago, we were just telling you we had this proof of principle and we want to go somewhere. So it's got to know that we have a group very well, a lot of enthusiasm in it. We're going to start this pilot. The idea is maybe by our next meeting, we'll get you the results. And we're going to work on this technology swap. So the little low-hanging fruit things that we could do along the year. We will start discussing about if it's still that in vivo study, it is something we want to try. And the idea, if the pilot works and we have at least these sample sets, we can start figuring out how to go back and do them. So we're moving forward, and I think this is it. I'm going to say thank you to all our contributors and Megan and Connie. And the questions, any questions?
Thank you, Patricia. Please feel free to drop something in the chat or raise your hand.
Oh, it's okay. We can have more time for the break. That was your question. Go ahead. Jan William, go ahead with your question.
Thank you. I have the following question. You are discussing the example of the PCB 126 and try to differentiate as a non-genotoxic carcinogen to differentiate between the non-tumor and the tumor inducing dosages and effects. But if there is a continuum in the effects of the compounds, for instance, in a pharmacological dose-effect relationship, is that an approach that has a promising result? I have the feeling that and based on the data sets that we have analyzed in the ICH project on S1B, that non-genotoxic carcinogens have a type of pharmacological dose-effect relationship in tumor induction. And from that point of view, I'm a bit hesitating with respect to that differentiation of what is the right tumor dose. Do you see what I mean?
Yeah, I know what you mean. I don't think we're going to detect a tumor dose per se. I think what we're trying to do, if it works, it is that, do you have an early indication, combined, of course, with your transcriptomics? When you have the transcriptomics, do you have an early indication of the potential forming a tumor based on the mechanism you understand? You have to know by the transcriptomics if it's a CAR or an AHR or something else that is driving that mechanism. You have already ruled out genotoxicity, because that starts very early. So it has to be when you have that finding in the transcriptomics that you want to kind of follow up.
Yeah.
I think that the challenge, of course, the challenge is that not all the clones form tumors. And I think that's one of our biggest challenges that we have to figure out as we go. Because what is that threshold that passes through, that is that clone, that is going to be a clone and nothing happens, or that clone is going to really turn out into that tumor, into the 2-year CARSO study.
Yeah, I think I have a similar problem with the project that was first, or the second, the molecular point of departure. I have the similar feeling that the toxicological approach is different from a pharmacological approach, and I'm not sure that what is the real scientific, an appropriate scientific approach in this area. But
I know. I think that's one of the main questions, but I think that would be the one we need to kind of keep in mind as we move forward and see can we answer it. Yeah. Thank you, though.
Yeah. Thank you.
One question.
Oh, go ahead.
I kind of have one that's come up within our group a few times for Patricia and Megan. Are there any thoughts? We're really in the in vivo space right now, but have there been like thoughts to applying it to in vitro? I know we're a ways away, but the thoughts on kind of applying there from your point of view?
Well, carcinogenesis in vitro is a very, very tough to really do. There are very few things that have been out there and they're not really the best. So I think still genotoxicity is it, genotox endpoints, but that will be for genotoxic mechanism. I don't know for non-genotoxic mechanism. I think the transcriptomics make more sense at this stage, but doesn't mean we cannot use the technology in vitro. We're doing it for the gene tox in vitro. So from there, when we learn more, maybe. That's my personal opinion right now. I don't know anybody else, please chime in.
Well, at least for carcinogenesis, there is a study that'll be coming out. I'm not quite sure if it's been accepted yet, but from NCTR, we're looking at using duplex sequencing to quantify mutation frequency in vitro 3D cultures. So that will be coming out soon. But as far as a non-genotoxic carcinogen, I don't know.
I don't think so. Yeah, I think it would be useful maybe for genotoxic carcinogens, but not. But thank you though, Connie, for asking.
It just always seems to come up, so it's nice to see like what the current state of where we are it's for.
Yeah.